we are going to discuss about resistors in parallel connection in this class now. Okay, so last class we have discussed about resistors are in series connection. Now we are going to discuss about parallel connection. Okay, so now this is the resistor, right? So these resistors, if you are connected like this, okay, so every resistor have plus and minus, plus minus, plus minus. One side is plus, other side is minus. This connection will be called as parallel connection. So if you connect this with a battery, source of battery of voltage V, then this will be called as parallel connection. So this resistance may have R1, this resistance may have R2, and this resistance may have R3. Okay, so here 3 I have connected. Then how 2 can be connected? Here one resistance, here one resistance, it will be connected. This is the two resistors. So let it be R1 and it will be R2 and this will be a voltage, right? So this connection will be simply called as parallel connection. I will give one hint here. So this is a single wire is passing from this wire, two wires are separated. If two separated, then this total connection will be parallel. That's all. Here see, here three will be separated, parallel. Okay. If only in single line everything is there, then that connection will be called as series connection. This connection will be parallel connection. Okay, got it now? Now I am going to discuss for two resistors in parallel. Both are going to be connected in parallel now. So this is the one resistor of resistance R1, and I have another resistance also of resistance R2. Both are connected to the source of potential V. Okay, right. Now let assume the current I is passing through it. So till here current I comes. Now what will happen? Here some amount of current, here some amount of current pass splits now, right? So this how much amount of current? This is I1. So here the current is I2. Okay. So in this case here I1, in this case here I2. Again together will forms total current I. For example, here I will give 10 amperes. Here in this some amount of will goes here, some amount of will goes here. So the total current will be I equal to I1 plus I2. Again it will be comes to same total current. So I equal to I1 plus I2. In parallel connection, potential is constant. V equal to V1 equal to V2. Okay, potential is constant as the combination is parallel. In series connection, which is constant, current is constant. In parallel connection, potential is constant. Okay, very important point, you have to remember it. In series connection, current is constant. In parallel connection, potential or voltage is constant. Okay, so already you know the formula. What is that? According to this Ohm's law, what will be is V equal to IR, general formula according to Ohm's law. So for V1 it is I1 R1. Similarly for V2 it is V2 equal to I2 R2. Okay. So now here everything will be equal only, no? That means this also will be written as V, this also will be written as V. Okay. So from this I1 equal to V by R1. Then from this I2 equal to V by R2. Okay. Now this I1, I2, and from this I equal to V by R, total voltage, total current, and total resistance. Total resistance is parallel resistance. Okay. All will be added. I1, I2 will be in this equation. Then what you will get? I equal to I1 plus I2. So I is nothing but V by Rp. I1 is nothing but V by R1 plus I2 is nothing but V by R2. Okay. So in this, which is constant? Potential is constant. So potential gets cancelled. Then 1 by Rp equal to 1 by R1 plus 1 by R2. Okay. So this is the formula to find the resistors in series, sorry, parallel. So here how many resistors? Two resistors. So it will be 2. If it is one more, then it is 1 by R3. If it is one more, then it is 1 by R4 plus and so on, like this we can connect. Okay. If these two resistors are same resistors, identical, then 1 by Rp equal to 1 by R plus 1 by R. So it will be 1 by Rp equal to 2 by R. From this, what is the resistance in parallel? It is R by 2. So here how many resistors? 2 resistors, so it is 2. If there is an n resistors, I mean n identical resistors, all are having resistance R, then Rp equal to R by n. Okay, what is the ratio of potential here? V1 is 2, V2 is 2, V3 is equal to 1 is 2, 1 is to 1, equal, right? Then what about the current? Current is nothing but it's a V by Rp, V by R1, V by R2. So current I1 is to I2 is to I3 will be equal to 1 by R1 is to 1 by R2 is to 1 by R3. Okay, so this is the ratio of resistance, sorry, current, and this is the resistance of potential. Okay, clear? So this is the one. Now we are going to see about problems on the resistors in parallel combination. So here one resistor, here one resistor. I am going to connect like this. Is this connection series connection or parallel? So single line, it is split it into two. So it is a parallel connection. So let's consider it is 2 ohms. This is 4 ohms. Okay. Let's consider here current is some 2 amperes of current passing. What will be the voltage? And what will be the current here, and what will be the current here? This current I will treat as I1, this current as I2. So now how to find this potential? First we need to find the resistance. How many resistors are there? Two resistors are there. So what is the formula? Rp equal to R1 R2 by R1 plus R2. From where it comes? It comes from this only. 1 by Rp equal to 1 by R1 plus 1 by R2. After LCM, it will be as 1 by Rp equal to R1 R2 by R1 plus R2. Here Rp is how much? Don't know. R1 is how much? Let's consider this as R1, this is R2. So 2 into 4 by 2 plus 4. So it is 8 by 6. It's 4, it is 3. So total resistance is how much? 4 by 3 ohms. Okay. Now what about the current? Current is there. We need to find the voltage. What is the formula? Ohm's law, V equal to IR. Potential, don't know. Current is 2. Oh, for example, let's consider 3 amperes. 3 into resistance. Resistance is how much? 4 by 3. So 3 gets cancelled. Potential is 4 volts. What is the potential now? Potential is 4 volts. Okay. Still what we need to find? Current of I1 and I2. So here what is the potential across 2 ohms? 4 volts. Across 4 ohms, same 4 volts only, as the connection is parallel. In parallel combination which is constant, potential is constant, equal potential. So now V1 equal to I1 R1. V1 is nothing but V. So what is that V? It is 4. Okay. So that is 4. 4 equal to I1. I1 is how much? 2 into resistance. Sorry. I1 I don't know. Right? I1 I don't know. No. So I need to find the I1. There is a resistance of 2. So 2 ones are 2 twos are. So I1 equal to 2 amperes. So what is the total current? 3 amperes. In this 3 amperes, 2 amperes will go here. Now then how much will pass here? 1, right? So 3 plus 2, sorry, 2 plus 3, 1. So now we'll check whether 1 ampere is passing or not according to the same Ohm's law. V equal to I2 R2. So potential is how much? 4. Current don't know. Resistance is 4. So 4 gets cancelled. I2 equal to 1 ampere. Right? I1 equal to 2 amperes. I2 will be equal to 1 ampere. Got it? Let's see one more sum last on this. Then here one resistor, here one resistor, and one more resistor. Let's take 3 resistors are connected in series. Okay, so this is 1 ohm, 2 ohm, and 3 ohm. 3 are connected in parallel. So what is the formula for resistance? I just need of resistance between A and B. I don't want to find current, I don't want to find voltage, anything. I just need of total resistance. So 1 by Rp equal to 1 by R1 plus 1 by R2 plus 1 by R3. So this total will be written as Rp equal to R1, R2, R3 by LCM, LCM, only LCM, nothing more than that. Okay, R1, R2 plus R2, R3 plus R3 into R1. Okay, so from this Rp equal to, okay, Rp equal to R1 is how much? R1, R2, R3. So 1 into 2 into 3 by 1 into 2 plus 2 into 3 plus 3 into 1. So now 3 2's 6 into 1 6. So it is 2 plus 6 plus 3. So now how much? 6 by 11. So resistance in parallel combination is 6 by 11 ohms. Okay. So this is the resistance in parallel combination. Okay. Next class we will discuss about combination of resistors in series as well as in parallel. Combined together it is there. Then how the circuit will be, how the current will be found out, and how the potential will be find out. Okay.